I am Anil Kumar sharing with you a recent test paper on trigonometry. You need to know basic trigonometric ratios, sine law and cosine law to solve these questions. So there are 8 questions here. You can actually pause the video, copy these questions. I'm going to take them one by one and then we'll see how to solve them. And I hope that is going to help you to prepare for your own test, right? So these are the 8 questions. Now let's take them one by one and solve them. You need to work with a calculator. The settings of the calculator should be in degrees. Question number 1. Solve the following triangle. The triangle given to us is a right triangle. So to solve means to find all the angles. That is to say, we should find what these angles are and also the side DE. Now since this is a right triangle, we can use SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent to solve. We can also use Pythagorean theorem, that is a square plus b square equals to c square, where c is the hypotenuse, right? So you can use any of these techniques to solve this particular triangle. So for example, if you have to find DE, we can use Pythagorean theorem. So we can say DE square is equal to the longer side, which is 5.2 square, minus smaller side 3.1 square, right? And therefore, let's calculate with the help of a calculator, right? Square. Or you can say DE is equals to square root of 5.2 square minus 3.1 square. So we can say square root of 5.2 square minus 3.1 square is equal to 4.174, correct? Now since the dimensions are given to one decimal place, we'll actually round this to one decimal place and write our answer as 4.2 and the units are meters, correct? So that is one way of solving it. Now to find the angles, since it is a right triangle, we can actually apply the trigonometric ratios to find the angle. Now if I have to find this particular angle, angle F, then what is given to us is adjacent side. This is the adjacent side and that is the hypotenuse. The ratio which works with adjacent and hypotenuse is cosine. So we can write cos of F as equal to 3.1 over 5.2. And from here we can say angle F is equals to cos inverse of 3.1 over 5.2. And again let's use the calculator. Shift cos inverse within brackets 3.1 divided by 5.2 bracket close equals to. So that gives you angle in 53.40 degrees, right? Okay, so rounding to one decimal place, we could write this as 53.4 degrees. So we have this angle as 53.4 degrees. Now to find the angle D, you could use sine of E, but it is better to use the strategy that the sum of these three angles is 180 degrees, right? So angle F is known to us, so angle E will be equals to 180 degrees, take away angle F, take away angle D, which is 90 degrees, correct? So it is equals to 180 degrees, take away 53.4 degrees, take away 90, right? So we'll do this as 180 take away 53.4 take away 90. That gives us in decimals 36.6 degrees, correct? So I hope the steps are absolutely clear. You can try the same exercise by finding first angle E and then the angle F. That could be a practice question for you. Let's move on to the next question, which is question number 2. And here, what we need to find is the length of indicated side. The side is SR, which is written in lowercase p. So in any triangle, side opposite to the vertex name is in lowercase. Vertex is given in capital letters, correct? Now here in question 2, the triangle given to us may or may not be a right triangle, correct? Now what we will do here, since the two angles given to us, we could actually find that angle also. But the best thing is, since we are given two angles, one, we can find the third angle using these two angles, correct? So we can say angle S is equals to 180 degrees, take away sum of these twos, or 39 degrees, take away 61 degrees. So that is the first step. Find the unknown angle. So 180 minus 39, take away 61. 80 degrees. So this angle is 80 degrees. Now here, since the triangle is not a right triangle, we can apply sine law to find the given side. So knowing this combination helps to find P. So side P, we are applying now sine law. So we could write P over sine of angle P, which is 39 degrees, is equal to what is given to us, 15 over sine of 80 degrees, correct? So P, the side length, is equals to 15 times sine of 39 degrees divided by sine of 80 degrees, correct? So let's use the calculator to find this answer. 15 times sine of 39 equals to divided by sine of 80. That gives us 9.58. We can round this to 9.6. 9.6 meters. So at times they will mention rounded to what, right? So if they say nearest whole number, then you have to write 10 as your answer, correct? Okay. Question number 3 here is find the measure of indicated angle. Now in this particular case, we are given 3 sides. So if 3 sides are given to us, in that case, we have to apply cosine law to find the angle. So you can write cos of f. That is what we have to find. So, well, some students may not remember this formula. So let me derive it first. Then we will use the formula, okay? So sometimes we write this formula as this side, let's say, we say 2.9 square is equals to these two square. We'll add them, 3.5 square plus 1.5 square minus 2 times these two sides, which is 3.5 times 1.5 cos of the angle in between. So cos of angle F, right? Now if you don't remember the formula and you remember this form of the formula, that's what I'm trying to say, then you can rearrange, right? So we can now rearrange and write 2 times these two sides product, which is 3.5 times 1.5 cos of F equals to 3.5 square plus 1.5 square minus 2.9 square, and then cos of F is equal to all this plus 1.5 square minus 2.9 square over 2 times 3.5 times 1.5. Is it okay? So the formula is very clear from here, is kind of like this. So if we are looking for the angle F, then we have to write square of these two sides, right? So which is, may write d square plus e square minus 2 times, minus f square, minus f square divided by 2 times product of these two, which is d and f, 1.5 times 3.5. And then we can find the angle f, correct? So that is how you could find angle f using cosine law. So let's calculate this answer and then we'll find inverse. So we have 3.5 square plus 1.5 square minus 2.9 square, and we'll just calculate this answer. And then we are going to divide this by, let's put it in brackets, 2 times 3.5 times 1.5 is equal to 29 over 50, let's say. Or you can write it in decimals as 0.58. So now you can say angle F is equals to cos inverse of 0.58, correct? So we'll do shift cos inverse of our answer, right? Which is 54.54. Rounding to one decimal place will give us 54.5 degrees, right? So that becomes the answer for this particular question, correct? So I hope the steps are very clear to you. Otherwise, you could have straight away used the formula and then found the answer. Okay, let's move on to question number 4, which is determine the length xy. So the length which we have to find is this length. What we are given in this triangle is these two angles. The smaller angle is 54.5 degrees, the bigger angle is 65 degrees, and the side opposite to the smaller angle is 38.7. Correct? So now you have to find this. So you can actually pause the video, answer this question, and then look into my suggestions. Now, one way to do this is, since we know one of these, we could use with tan theta also. We can find VW and then we can find the total length. So what we will do here is that we'll consider the triangle, the smaller triangle, XVW. So this right triangle, the angle is 54.5. So we will find VW from here, correct? Using tan, right? So we know tan of 54.5 degrees is equals to, opposite side is given to us as 38.7. And let's say this height is h. So we can find the height h from here, which is 38.7 over tan of 54.5 degrees. 38.7 divided by tan of 54.5 degrees. That gives us 27.6. Now, once we know height 27.6, we can now look into the bigger triangle. So now we'll consider the triangle YVW. Correct? Now here the angle is 65, and again we'll find tan, right? So we say tan of 65 degrees is equal to the side YW divided by height h. And we have to find YW this time, but height is known to us as 27.6. So let's recalculate and find what YW is by cross multiplication. So we get 27.6 times tan of 65 degrees, correct? So we get 27.5 times tan of 65 degrees. So that gives us as equals to 58.97. Correct? 58.97. I'll round to one decimal place as 59.0. Correct? I'm rounding to one decimal place. Now, since we know that now YW is 58.97 or rounded to 59. This is the total length. We can find what xy is. It's the difference of these two. So we'll just write 59.0 minus 38.7. Correct? So let's do this. 59 minus 38.7. And that gives you in decimals 20.3. The units are in centimeters. Correct? So that is how you can actually find this particular side, correct? Or this particular angle. There could have been an alternate way of doing using sine law, which I am not using in this particular case. However, you could use it, right? Because difference of these two angles will give you that angle, and we could always find this side and we can find that angle. Since this is 90 degrees, we know this angle. So let's see the approach. Now we'll say alternate method is to find angle y. So angle y is equals to, this is 90, we are looking at big triangle, is 90 minus 65 degrees. Is it okay? So that is 90 minus 65, which is 25 degrees. So you know this angle is 25 degrees, correct? Also we know that angle. That angle is known to us because it is difference of these two. 65 minus 54.5, which gives us in decimals 10.5 degrees, right? 10.5 degrees. Now if I find this side, correct, which I can because I know this side, and this is a right triangle, so I could use cosine. This is opposite, so sine of 54.5. Let me write down. So we know xv is equal to, we can always write this as 38.7 divided by sine of this angle 54.5. Correct? So once you find this side, you can apply sine law to find yx, right? So that is the alternate method, apply sine law to get the answer. So I'll leave this second method for you to do, correct? So I hope the steps are clear to you. So you should do it, okay? Question number 5. Evaluate 3 decimal places using calculator. So this is a simple question. We just have to use calculator. Sine 140 equals to, it gives us 0.6427, and you have to write to 3 decimal places, that is 0.643, right? Similarly, do the others. So we have cos of 110 degrees, which is negative 0.3420, so it is equal to negative 0.342. Now cosecant, how will you do cosecant? Now we have only sine, cos and tan here. So to do cosecant, we have to use the reciprocal ratio, right? So cosecant is reciprocal of sine, so it is equals to 1 over sine of the angle 130 degrees, correct? So we'll divide 1 by sine 130 to get cosecant, and whatever we get, in this case it is 1.3054, we'll round that to 3 decimal places, which is 1.305, correct? Now the last one here is secant, which is reciprocal of cosine, so it is cos of 65 degrees reciprocal, right? So it is 1 divided by cos of 65 degrees, and that is 2.366. So we'll round it to 2.366. So I hope the steps are clear. So here we have used reciprocal identities to calculate the value. Question number 6. Now in this case, we are given the trigonometric ratios. We have to find the angle. Please note that angle A is within 0 to 180 degrees. That is to say that in our quadrant 1 or in quadrant 2, correct? That is 0 to 180 degrees. We are looking for solutions in this area. Now you also remember that all are positive here. Sine is positive in quadrant 2, tan in 3, cosine in 4. So if sine positive value is given to us, we are looking for two solutions. One in quadrant 1, the other one is in quadrant 2. Remember that. For cos, positive means only in quadrant 1, correct? Secant, positive means only in quadrant 1. Tan, 0, that is when sine is 0, right? So this you could straight away write, tan is 0 for 0 degrees and for 180 degrees. So let me write down here as 0 degrees and 180 degrees. So it has two solutions. Okay, so we've said all that. So let's now find the angles. So first one, cos A is 0.7. So A is cos inverse. So what we do here is find angle A as equals to cos inverse of 0.7. Is it okay? So use the calculator. We say shift cos inverse 0.7 equals to. So we have 45.57. So which is 45.57. So we'll just round it to one decimal place. We'll write this as 45.6 degrees. Is it okay? It is important to write degrees. Now sine A. Now remember, sine A could be in both the quadrants. So let's find first angle A as sine inverse of 0.568. So what we get here is sine inverse of 0.5686 equals to. So it gives you one of the angles. So this angle is 34.652. So I'm writing this as 34.7 approximately. So we get one angle here, which is 34.7. The other should be right there, right? So that angle. So the other angle is 180 degrees minus 34.7 degrees. Is it okay? So you have to get two answers. Remember that part. So 180 minus 34.7, which is equal to, in decimals, 145.3 degrees. So for sine, you get two answers. Perfect. Now secant is 1.5. So you can write what cos is. So cos A will be equals to 1 divided by 1.5. Is it okay? So first find what cos A is, and then we'll say angle A is equals to cos inverse of 1 divided by 1.5. So we can find angle A. So angle A is cos inverse of 1 divided by 1.5, which is equals to 48.18 or 48.2 degrees. The last one I did already, tan 0. Tan is 0 for 0 and 180 degrees, right? Now as a practice, you could add a question here and find what is the angle. If I say secant A is equals to 2.34, right? And find angle A. Okay, so let's move on. Now we'll take up the next question. Question number 7. Question number 7 is, the point minus 34 lies on the terminal arm of angle theta in standard position. Sketch the angle in standard position. Determine primary trigonometric ratios. So let us first sketch it. So we are given a point minus 3, so that means 1, 2, 3 minus, and 1, 2, 3, 4. So that's the point for us. So on terminal arm, so that becomes the angle, the terminal arm, right? So the angle for us is that angle theta. And this is the point minus 3, 4. Let's call this point P. So the point lies on the terminal arm, the angle theta in standard position. So theta angle is always measured from positive x-axis, right? So that's the terminal arm, counterclockwise. So that's the sketch. Now determine primary trigonometric ratios. To find primary trigonometric ratios, we actually consider this particular triangle, correct? And we need to uh, what we need to do here is, we know this side is minus 3 here, and that is 4. So we can find the hypotenuse. So we look at this triangle itself. Okay, so let me redraw the triangle here. So in this triangle, we know that the sides are 3 and 4. So we can find the hypotenuse, right? Minus indicates that anything to do with the adjacent side, let's say this is our angle phi, right? So this is kind of similar triangle where we know phi is equals to 180 degrees minus theta. Is it okay? Now, so let me say this point is O, this is P, and we'll call this point as Q. So we have PQ and O. So what is PO equals to? So PO is equal to square root of 3 square plus 4 square, which is 9 plus 16 square root, which is square root of 25 or 5. So we know this side is 5. Now you should remember that in this quadrant only sine is positive, correct? So what you know here is that all are positive here. Here sine is positive, tan and cos, right? That's the rule. Even otherwise, so we say sine of theta is equal to, so when you look at it, the opposite side is 4, so it is 4 over 5, correct? Now what is cos of theta? Cos of theta will be, adjacent side is minus 3, so it is minus 3 over 5, and tan of theta is the ratio of these two, right? So y value is 4 over 3 with a negative sign. Do you see that negative sign? So that is how we can find all the primary trigonometric ratios, correct? So as an exercise, also find the angle theta. So we can find angle theta as using one of these. Is that okay? To find angle theta. So what we will do here is, we'll first find angle phi. So what is phi equals to? We say phi is equals to tan inverse of 4 over 3, which is, let's find it out. So we have shift tan inverse 4 divided by 3 equals 2. So we get an angle of 53.13, right? Now this is definitely more than 90. This angle is that phi angle. We got that angle. Do you understand? So what is theta equals to? Theta equals to 180 degrees minus 53.13. So we always find positive angle. So we have the angle which is kind of here. So this is 53 point, let's say 1, right? So now we'll do 180 minus 53.1. And we get an angle which is 126.9 degrees. So for us, angle theta is equals to 126.9 degrees, correct? Okay. Well, that's not a part of this question, but it could be. Now let's look into the last question of this quiz, which is, two radar stations that are 150 kilometers apart located an unidentified plane that vanished from their screen at the same time. The station A indicated that the position of the plane made an angle of 44 degrees with the line joining the stations. Station B indicated that the plane made an angle of 56 degrees with the same line. How far is each station from the point where the plane disappeared to the nearest kilometer? So let's say these are the two stations A and B. Now from A, the angle of sight was 44 degrees. So let's say this is 44 degrees, right? So this is what we are saying as 44 degrees. And from B, it is 56 degrees. So let's say this is 56 degrees. So what we are supposed to find is these lengths, right? Let's call this point as C, and we want to find these sides, correct? So that is the question for you. Now in this particular case, what you can do, and we are also given the side between A and B, that's important, 150 in kilometers, correct? So let's find this angle first. So let's find the angle C first. So angle C is equals to 180 degrees, which is sum of three angles in a triangle, minus 44 minus 56. 180 minus 44 minus 56 is equals to 80 degrees. So once you have this combination, you can use sine law. So we'll apply sine law. Now what is known to us is this combination. Perfect. So we can write A over sine of angle A, which is 44 degrees, is equals to side of 150 kilometers over sine of 80. So A is equal to 150 times sine of 44 degrees divided by sine of 80 degrees, correct? So we get 1. We can always calculate this. Similarly, for this also we'll say B over sine of 56 degrees is equal to 150 over sine of 80 degrees. So B is equals to 150 times sine of 56 degrees divided by sine of 80 degrees, right? So let's use the calculator and find these answers. We'll round them to nearest kilometer. Remember that. So 150 times sine of 44 divided by sine of 80 gives us the answer as 105.8. So rounding gives us 106 kilometers. The other one here will be 150 times sine of 56 divided by sine of 80, which is equals to 126.27. Rounding will give us 126 kilometers. Okay, so that is how we can actually solve this question. So I hope you understand all these solutions. So in this particular quiz, we have taken simple concepts based on sine law and cosine law. It's kind of an introduction to these, where the triangles are not really right triangles. Now we'll take up test and few more practice quizzes on trigonometry. Thank you and all the best.